So that brings us to what's called transformations of functions. So in order to understand this, I need to review with you. This really is review, I think, technically, the graphs of some common functions. We looked at some of these in the last section. So the first one, which we're actually not going to be using all that much, is f of x equals x. This one might come up in the homework, actually. Does not come up in any of my examples. That's just a straight line that goes up at a 45-degree angle, passes through the origin. All right, this one I think we talked about a little bit. This is f of x equals x squared. So what I want to point out to you about this, you might be asking yourself, what I'm asking myself is, where is my mouse? So let's, there we go. All right, so now if I, let's see. All right, we'll do this. It passes through points like 0, 0, 1, 1, 2, 4, and also negative 1, 1. This is not perfect. And negative 2, 4. So you could make a table and draw that graph. Okay. All right, two other ones I want to show you, and those are f of x equals the square root of x. So that passes through points like 0, 0, 1, 1, 4, 2, because the square root of 4 is 2, and then 9, 3, way over here. All right, again, we looked at something like this in the last section. And then finally, f of x equals the absolute value of x. All right. Okay. So I have some activities for you here. If you're a student in my class, what I'm going, or what I will have done by the time you watch this, is posted a handout. So what I would love it if you would do would be to print that handout and do this along with me. All right. When I teach this class face to face, I throw out little bits of extra credit for people to come up to the board. Everybody works on this and then comes up and draws the graphs on the board. Okay. So activity number 1, I want you to sketch the following functions on the same coordinate system. Here are the functions. F of x equals the absolute value of x. And you don't even have to use the thing that I just showed you, all right, because you're going to do it using a table. G of x equals the absolute value of x plus 2. H of x equals the absolute value of x minus 4. All right, so pause the video, take the handout that if you're one of my students, this is posted in your module, probably right before this video, and try this and then come back and we'll compare notes. All right, so instead of doing this on my tablet, I've just got it all done here. So hopefully you got something that looks like this. Here is the table for f of x, and that is the graph that you see. It's kind of hard for me to tell what these colors are because they're sort of, I don't know, but that's blue, I think, some shade of blue. G of x is up here in red. And then h of x is down here. It's this sort of yellowish green color. All right. And what I want you to take from this is that those three graphs are the same shape. The only difference between them, again, starting with the blue one, is that to get g of x, you just shift everything 2 units up. And to get h of x, you shift everything 4 units down. Okay. All right. Next activity. We're going to sketch these functions. F of x equals the square root of x. G of x equals the square root of x minus 2. And g of x equals the square root of x plus 4. And again, I've given you 3 tables, and I have carefully picked these values of x. We talked about this a little in the last section. So to make f of x work out nicely, you can pick perfect squares for x. All right. So pause the video, try that, come back, we'll compare notes, and then we'll talk about what's going on in activity number 1 and activity number 2. So the next time you see a problem like this, you won't have to do it this way. You'll have an easier way. All right, so try that and come back when you're ready. All right, here it is. So funny story. Well, it's not that funny. When I was putting this together, I remembered that I had made a version of this for my trigonometry class about 1.5 years ago. And I was hoping that I could just use the same thing for you. But unfortunately, one of the activities was a little bit different. It uses a function that we don't really talk about in this class. So I had to change this one that you're looking at here. And I cannot remember what computer program I used to draw those graphs that you were looking at in activity number 1. So I don't think it was the same program I used to make this one. At least I couldn't figure out how to label which one was which. So I color coded them here. F of x is the one in blue. And then again, this color, I can't tell. I literally cannot tell if that's red or gray. It's some very dim shade of red, I think. But here is the big sort of surprise ending about this. So you can see what these graphs have in common. They have been shifted side to side. Notice that the one in red, which is g of x, has been shifted 2 units to the right from f of x. And that is kind of crazy because you see that -2 there and you think it's going to go to the left. All right. So this is something that really takes some getting used to. All right. It's kind of hard to accept that that's the way it works, but it really is. All right. And then the same thing for g of x. Relative to f of x, g of x has been shifted 4 units to the left, which again is surprising. You see that +4 and you think it's going to shift to the right. So what's helpful to remember about any kind of horizontal transformation, and in Math C, there's only this one that we talk about. My assumption for Math C students is that you're all going on to take trigonometry, whether or not that's actually true. You will learn about some other horizontal transformations in trigonometry. And what I like to point out about the horizontal transformations is that they all work exactly the opposite of how you would expect. All right. So that in and of itself hopefully makes it easier to remember. If you just remember, okay, it's horizontal, so it's not going to work the way I think it is, that should help you. All right. So what is the moral of the story to all this? Well, let's look. Okay, so on the one hand, you have vertical shifts. And the way that you make a vertical shift is like this. If k is a positive number, then the following graphs are vertical shifts of the graph of y equals f of x. Y equals f of x, and then add k on the end results in the graph being shifted k units up. Y equals f of x minus k on the end results in the graph being shifted k units down. So this one works exactly the way you would expect. Plus means up and minus means left. All right. Now for the horizontal shifts, again, these are the opposite of what you would expect. So now let h be a positive number. Then the following graphs are horizontal shifts of the graph of y equals f of x. So first of all, I want to point out the difference. Sometimes students ask, how do I know if the shift is even vertical or horizontal, let alone up, down, left, right? If the number is being added or subtracted right next to the X, that makes it horizontal. All right. So notice the difference between f of x minus h versus f of x, and then subtract k on the end. All right. So if the number is being subtracted right next to the x, that is a horizontal shift, and it's a horizontal shift to the right. Again, with this, minus means right. It's weird, I know. And y equals f of x plus h results in the graph being shifted h units to the left. And don't worry, we're going to do some examples of this now that you know the rule. All right, so you'll see exactly how the rule works. But first, I have one last activity for you. So activity number 3 is to sketch the following functions on the same coordinate system. F of x is x squared. G of x is the opposite of x squared. So please pause the video, try that, come back and compare notes. All right, so hopefully you have something that looks like this. F of x equals x squared is the graph in blue. It's the upwards opening parabola. G of x equals the opposite of x squared is the downwards opening parabola. Now, sometimes people do get confused with this one because of the way they plug in the negative numbers. So I just want to point out to you how that works. So if you were plugging -2 into function f, what I need you to understand is that that whole entire -2 is being squared. It is the square of -2, which comes out to 4. On the other hand, if you were doing this one down here, and I think you've seen me do this before, maybe, or maybe not in Math C. When I evaluate functions, what I like to do sometimes, no, you have seen me do this, is I like to write the function and just leave a blank space in place of the x. And so let me see if I can find, okay. All right, so when you put in that, there we go. So it starts out looking like that. And then when I put in the 2, it goes inside and the negative is outside. And that's why it comes out to -4. So you have to evaluate these things correctly. So what I want you to take away from this is that these two graphs are mirror images of each other across the x-axis. So reflection across the x-axis is the only kind of reflection we talk about in Math C. And the way that works is you just change your whole entire function to the opposite. All right, so you have your function, whatever it is, and if you stick a negative sign in front of the whole thing, which if your function has more than one term, that would mean you'd have to put it in parentheses. That is going to reflect the graph across the x-axis. In other words, it's going to flip it upside down. Okay. All right. So one last thing before we get into a couple of examples, and then we'll be done with this section. When you have more than one transformation happening in the same problem, the order is kind of important. So I recommend that you always do them in this order. First, do your horizontal shift, if there is one. Then do your reflection across the x-axis. And the most important thing is if there's a vertical shift, do that last. You can actually do the horizontal shift and the reflection in any order you want, but they both have to be done before a vertical shift. All right, so here are the two examples that we will end with. So we'll do the first one together, and then I'm hoping that I can talk you into trying the second one yourself. And you know how I do it. Pause the video, come back, we'll compare notes. Okay. All right, so let me bring up my tablet. All right, so first we have f of x equals the square root of x minus 1, and then add 3. So my first step is I'm going to draw the graph of square root of x. So that's one of my common functions, right? And that looks something like, I think I'll use green. The yellow might be hard to see. It goes through 0, 0, 1, 1, 4, 2, and it looks something like this. Whoops. Okay. So to get the graph that I really want, which is f of x equals the square root of x minus 1, add 3, notice that there are two types of shifts happening there. Well, let's start with the easy one. The plus 3 on the end means shift 3 units up. The minus 1 next to the x means shift 1 unit which way? 1 unit right. All right, that's the one that seems backwards. Okay, so for this one, we're just taking this graph and shifting it 1 unit to the right and 3 units up. So it's nice to have a few sort of reference points on there, because then you can do that to each and every one of those points. So if you shift this one 1 to the right and 3 up, you end up here. And if you shift this one 1 to the right and 3 up, you end up here. And if you shift this one 1 to the right and 3 up, you end up here. All right, and then you just draw a graph that's the same shape as your sort of reference graph. So much easier than making a table. All right, so now I'd like you to try letter B, which is g of x equals negative absolute value x plus 1, and then add 1. Please try that one similar to how you saw me do the last one, and then come back and we will compare notes. All right, so hopefully you tried that. I will admit this one is just a tiny bit more complicated than the one I did in letter A. So it's going to start with drawing your basic absolute value of x graph, which is that letter V that we talked about. It looks like this. And it goes through points like 0, 0, 1, 1, 2, 2, and also these points. Okay. All right, and we actually have all three types of transformations happening in this problem. We have a horizontal shift, a vertical shift, and a reflection. So which direction are those horizontal and vertical shifts going to go? Well, let's start with the horizontal shift, because that's the one you do first, right? So when you put a plus 1 right next to an x, that means shift 1 unit to the left, 1 unit left. So here's what I'm going to do. Well, I'll do it in red since I've got that color up. Just draw this graph, shift everything 1 unit to the left. And you know what? I'll do this as a dashed line so that it's super clear at the end what my final answer is. Okay, looks something like that. All right, next I'm going to do my reflection, and I'll do that in blue. So the negative sign outside tells me that I do a reflection across x-axis, which is the only kind there is, right? All right, so that graph that we just did in red, you're just going to flip that upside down. So this point is going to stay exactly where it is. This point here is going to come down here. This point here is going to come down here, et cetera, et cetera. And again, I'll do this as a dashed line so that everybody can tell it is not my final answer. Okay, and that brings us to the last step, which is the vertical shift. The +1 on the very end of the function means we're shifting 1 unit up. The last thing we drew, we're going to shift it 1 unit up. So because this is my final answer, I'll make a nice bold line for this. Just take those 3 blue points there and move them all 1 unit up. All right, so what you're going to get in the end is going to look something like this. This is the graph of g of x. All right. So there's quite a bit that goes on in this section. You know how it works. Just start trying the homework, and whenever you run into trouble, just reach out for help. All right. That's going to take care of section 8.3. We'll see you next time.